Alright, sorry about that. I think my mic was muted there. Basically, we're gonna be starting in a couple minutes. If you haven't already, please go down into the description and sign in. Really appreciate it. Oops, sorry about that again. Yeah, so go ahead and sign in. We really appreciate that. If you have any questions, feel free to post them in the chat. I'll be trying to look at them as I go along. And yeah, also if you have any technical questions about trying to get started, or like, hey, did this, but can you do this instead? Feel free to post them as well. Yep, and also this will be posted on our YouTube channel later tonight, so if you can't watch the entire thing, feel free to just stop and then watch it later as well. But yeah, I'll get a couple minutes and then we'll get started. Alright, so I guess we'll go ahead and get started. So I'm working in the visualization Matplotlib repository on GitHub, so if you want to follow along, please download it from there. But I'm going to go ahead and get started. So like I said, please sign in and you can download it out of this GitHub link. And you can see all of our other links for our socials at Facebook, LinkedIn, and GitHub right here. So you can just literally click it and you're good to go. So what is Matplotlib? So Matplotlib is a Python visualization library that is designed to be similar to Matplotlib syntax and use NumPy and pandas, arrays, and vectors to create amazing 2D plots. Visualizations are very important because they allow you to identify trends, correlations, and patterns in the beginning stages of data exploration. Additionally, they're a great way to present any knowledge you've uncovered once you perform data analysis. So I would say this is probably, well, I know this is a really important stage, especially for when you finish your project, you presenting your thoughts. So whether you're showing like how your model performs, or it could be at the very beginning when you're trying to figure out, okay, I have a data, what's correlation look like, what are the trends of my data. This is very important no matter what stage. So very good. Matplotlib is kind of your standard library in Python. It's great for doing graphs and plots and kind of like that. There's other libraries like Seaborn, it's a little more simplified, that kind of like sit on top of Matplotlib, but if you learn Matplotlib, you'll be very well set off. So first thing we're going to do is we're going to import our necessary libraries. So like any notebook, I feel like in data science, you start with your pandas as PD, import numpy as np, whoops, import, and then matplotlib.pyplot. This is the module that lets us plot in the Jupyter notebooks, and then the common syntax is plt, plt, and then the next thing you do is you do like you do the magic command of I think it's matplotlib or inline. Yeah, so you do matplotlib inline. This just makes it so the plots are within a notebook. So we run this, we should be good to go. And if you also notice here, we have this Pokemon CSV. This is what data we'll be visualizing. You guys can do with any data set. It's not just Pokemon, so feel free if you have different data set, go ahead. But we're starting this one. So import data. It's a basic command of data equals in your pandas read underscore CSV. We're gonna read it. So it is Pokemon dot CSV. And then I just want to kind of show the beginning of it. So I'll do data.head. So as you can see here, this is kind of our data set. So we can see that your index here, but the number basically, I think in the Pokedex, the name, the type 1, type 2 if they have it. For example, something like Charmander only have 1. And then their total, which I think is just a sum of the other attributes. Then they have things like HP, attack, defense, special attack, special defense, speed, whatever. I think generation is what island they're on, something like that. It's basically like, I think they multiple generations. They start with the first one. Now they have like generation 10. And then legendary is like, there's certain Pokemon that are like extra special and they're legendary. So that's kind of it. So now let's make some plots. So considering the idea that, say we have two types, right? And we want to compare them. This will, we want to compare them. So say we have, we want to compare grass types versus fire types attack, right? Easy way to do that would be a box plot where basically we can show, all right, one on average, the mean is higher and the interquartile range is higher, the other one. So let's start with the box plot. So, um, yeah, so for example, this one says we want to compare the HP between water and fire types. And like I said, it would show good the variance in mean as well as like interquartile range and those kind of things. So first thing we have to do, unfortunately, is we have to actually pull data from it. So we have this big data frame and we only want the grass and water types, right? And so what we have to do is let's call this variable like box plot underscore or data. And let's just, before we do two, let's just do one. So let's just try to get all water Pokemon, right? So what we would do is we would do data dot lock, or sorry, yeah, lock, or yeah, let's do this, data, yeah, so data dot lock, and then we'll say data, and then we'll say when the type 1 is water, or sorry, when the type 1 equals water, dot values. So I believe what this will do is if we then show boxplot data, this will only give us water types, right? So that's good. And then we only want, so that's good, right? So now we only want to get the HP values, right? So we'll do dot HP. So let's try this. Or actually, let's subset it by doing something like this. We'll get and let's just get HP, just HP by itself. So yep. So these are the HPs, and we'll do that values. So this is all the HPs of all the water type Pokemon, right? And if we want to compare between water and fire, we basically have to repeat this, but just change this from water to fire, right? And then we'll make this into a 2D array, or yeah, 2D array. So we see now we have all of our water types in this array, and then all of our fire types in this array. So it looks like there's probably, based on expansion, more water types. But we're good to go from here. So we can don't show us anymore, and let's create a box plot, right? So the easiest way to do this would you call the library, and then you do box plot, and then you feed it your data. So we do that. Whoops. You can see here that that you have your water types here. You can see that the variance on your water types is a lot higher than your fire type, and it looks like they have approximately the same mean. And this one has a little more outcomes. So first thing we should do is that when you see all of this kind of stuff, the way you resolve that is you fix this by doing plt dot show, if I can type, and it instantly goes away. So that's your first thing. That's like a good way to remove a lot of clutter. The next thing we want to do is we probably want to put axes on the x and y. So if we want to do that, we do plt.x label, and then yeah, so this we can do something like Pokemon type. We can do the same for y, plt.y label is, for example, HP. So if we do that again, okay, see Pokemon type 1 and 2, which we want to fix again, and then HP. So the way we fix that, the Pokemon type 1 and 2 instead of, water and fire, we can do that by doing, we will do labels equals, and then we're going to pass it in. So we did water, fire. And there you go. So that's kind of your first basic like box plot. You can kind of see here that HP on the y-axis, Pokemon type on the x-axis, and we can generally see what's going on. Let's stop for a second and see any questions. Alright. One other thing we should take note here that you can also do a lot more adjustments. We're just getting started, but example, this is font size, so you can change the font size. Let's say just something ridiculous, say like 20. And you see here that it's just really big. So you can do a lot of different stuff with customization, but we'll just keep it simple at the beginning. So this is a very, like I said down here, this is a very basic box plot comparing water and fire type HPs. But let's say if you want to compare all of them, make them visually appealing. So this right here is pretty boring. If this was a series presentation, which we know it's not, but if it was, it'd be pretty, boring, not very colors. Let's make more visual appealing as well. So nice about Matplotlib is that you can do very basic stuff like this, but also you can do very advanced stuff and kind of change everything. So let's get started with that. So the first thing, I want to do is we want to get some color in here. So best way to do that is to do import matplotlib.color. Was it color? Maybe it's just .cm. Yeah, this is like the color map, I believe, as CM. So this will let us like basically select colors. So that'll basically fill it in later. Next thing we can do is what we want to do is that instead of doing all of this, basically like manually doing, let's create a for loop. So we can say for type, let's say pokey underscore type, and actually let's do this. So let's say the type, the pokey underscore types equal data dot or type 1 unique. So if you see here, what this does is that it gets all the types. So now let's try to iterate through. So instead of, before we were just changing this value here, we can iterate through it. So we can say for p, let's call it p underscore type in pokey type. What we will do, and let's start with the empty array, right? So let's call this box or data. What we're going to do now is we're going to say box data dot append. So we're going to add it on to the end. Then we can just basically copy this up here. But instead of doing water each time, we'll do the pokey type. Or p underscore type, sorry. So basically now this will get the HPs of all the different Pokemon types manually instead of us having to manually going back and forth. Another thing we can do here is that we want to get, so we know we have like all these types, right? We want to create a color map where each one is different colors. So what we can do is we can kind of create a rainbow effect by creating this colors variable by saying cm dot, sorry, as I'm looking over, rainbow equals np dot len space, I believe, len space. And what this does, it creates numbers equally spaced between 0 and then and 1, which will be all of our different colors. And then the last variable you pass in, or parent you pass in, is the number of objects you want to do. So we'll just do the length of our poke type. So I know it's a little confusing, but also we kind of refresh here. So we get all our poke types, and then what we do is we iterate through each one, and then we add all the HPs for that type back to this box data value. And then at the very end, we also create this like color palette, which we'll see later on, by basically creating a rainbow where each color can be represented by like a decimal between 0 and 1, and we get equally spaced ones by the length of our number of types. That's what this line space does. Alright, so now we kind of have our baseline data. Sorry, what is, whoops, gotta fix this. I didn't declare properly. There you go. Alright, so let's actually create our plot. So the one thing that I don't necessarily recommend you doing, you can do this at the beginning, but I wouldn't recommend doing this, where you just basically leave like this figure just floating around, on your Jupyter notebook. What I recommend you do is you create like a figure object and then you assign values to it. So the way you do that is you use fig equals plt dot figure, And then you can assign it, for example, a size. Sorry to look for it because this is syntactically a little strange. And then you can add like DPI as well. So now you have this figure that you can like basically plot on, right? So the next thing you can do is you can do, for example, plt dot plot or box plot, sorry, and you can do your box underscore data. Oops, you have to do plt dot show still. So now you have all of your different plots, as you can see here. And I'll move this over a little bit. So as you can see, you have all of your different Pokemon types, right? And yeah, so you see it's like very like obviously complete, but it's not very helpful yet because we don't have any colors, we don't have any labels. Let's kind of add our labels back, right? So let's do we can copy this from up here because it's gonna be the same regardless of the plot. We can also do is add the labels again. Equals, but instead of doing manually where we had the array, we're just gonna do poke type. Right, so let's show it now. So now you can see we have all our different Pokemon types. So we have, you know, grass, fire, all the way down to flying, our Pokemon types. Another thing we can do, let's add, so now let's add some color, right? So the first thing we have to do is we have to set this variable in our box plot called patch artist. So patch underscore artist equals true. And that basically allows us to add color. And then what you do is you say for patch, oh sorry, I forgot. So you basically now have to like, we're gonna go in and edit our colors of each box plot. So you basically assign your box plot to this variable called box, and you say for patch and color in zip, and I'll explain this in a second. Box. Alright, so what this will do, so basically so the zip command basically allows you to iterate over two things at the same time, assuming that they're the same length. So box is what it does is it go, so since we have this variable box that contains all the information, what this is doing is we're allowed to go through each individual box plot, this entire box plot, but each of the individual boxes, and this is for each individual color. So basically what we're going to do is we're going to inject the color into each individual boxes where the patches are individual, for example, grass one here, then we'll add a color. So we say patch dot set color face, yep, color. I believe, whoops, is it not? Oh, sorry, face color. Okay, what happened here? Sorry, let me look at my notes really quick. I think we have to do this really quick to list. There you go. Okay, so one thing that happened was, okay, let me show you, I guess. So before, I have to print, whoops. So before this was, let's do this. This was an ND array, and unfortunately, doesn't necessarily work. So we have to just basically, if you do the to list, it basically converts from ND array to just a normal Python array, and then allows it to work. I know it's kind of like a weird thing for why that happens. Just it's something you have to play around with. But yeah, so we do this. We can see here now we have a very aesthetic plot. It's probably not the best. It's kind of hard to create individual colors, but this is an easy way to use this rainbow. But as you can see here, you have your flying types, and it's very easy to distinguish between all of them. It's a little more aesthetic. Yeah, do you have any more questions? I'll stop for a second. Yeah. But yeah, essentially this is just a way you can add doing this where you place a figure down, you create your box plot, you can get assigned to a variable, and then you go through each box within the box plot you assign a color as a way you can add a color. Yeah, so let's make sure no questions. Alright, okay. So as you can see, you can heavily customize it. What I did here is just scratching the surface. Most likely if you were just to do this yourself, you could probably just like Google it or look online, find additional information. Like say you want to make dollar signs, Google it, you'll find an answer. There's all kinds of different documentation online. So if you ever need help, just go online. I promise you, there'll probably be someone already did the same exact thing, and you can just copy paste code. Just make sure to cite it. So yeah, so I have here all the different functions that you can like look up, and if you want better understanding of it. The next thing is scatter plots. So scatter plots are another great way. They allow you to see like trends and correlation between two variables. Or for example, say you're plotting a linear regression, you kind of see, you want to see like a singular, simple linear regression, you kind of want to see the relationship. So it's kind of same thing as before. If you do PLT, well, let's compare between special attack and speed. So let's do PLT dot scatter plot. Sorry, as I make sure I'm dot scatter, and then we're going to pass into variables. So you data, and we'll do special attack, and we'll do the other one of data speed. So as you can see here, I add plt.show. As you can see here, there's some kind of positive correlation going on, where the greater the special attack, the greater the speed. So this is a very basic plot. Let's again, add some axes. So plt.x label. This is our special attack, and this is plt.label. Is our speed. What else could we do? Oh, we can also add a title. So a title is another way. So, we have this, we've done this before. Let's add a title. So something at the very top. So plt.title. And we can comparing. I can't spell apparently. Speed versus special attack. So you can see here now we have a kind of a title. And yet again, we can do all the same stuff where you can like increase the font size, all that kind of stuff. So if you're interested, just Google it. The syntax is always a little funny, but you can definitely do it. So we see some kind of positive correlation going on, but what if we want to kind of see like, okay, are some populations have a higher, like for example, like would it be interesting? It'd be interesting to see like, okay, if this population appears as like mostly one type, and then this mostly a different type, and so on and so forth. So the best way to do that would probably be add color to each dot specifying the type, right? So let's go ahead and get started. So yet again, what we need to do is we need to do the whole, we need to add the figure, right? So fig equals plt dot figure. Let's just make this big again. So let's just make it 16 by 12 with a DPI 60, and let's make the face color. So that's another customization you can do. You don't have to do it by any means. I just kind of want to show you some of the features that are possible. So let's add. So we have this. I mean, we can just do this. We can see nothing really happens. We should also do plt.show in anticipation that we're going to plot. So the first thing we can do is we can do the same thing again, where we have our. We can do this basically each time, right? But the problem is So let me stop. So the way we have to approach it, so each time we have to basically apply all the colors on top. On basically, we're going to plot multiple graphs on top of the same figure, and each time we're going to plot a different types relationship. So let me explain. So we're going to say for poke type, and then oh sorry, let's just call this index. Let me just write it out first, and then we'll do it in zip poke type range. Okay, so I know it's might look confusing, but I'll explain it once it's done. So what we'll do is we're going to iterate over each Pokemon type, and then we're going to use indexes as well. So this is basically, this shows the Pokemon type, and this is going to allow us to get the index of the color. So, actually we don't need this. We can just do in color. Yeah, let's try this. So we can do plt.scatter, and then what we're going to do is we're going to do data. We're going to do the same thing. We're going to get the special tag. But then what we're going to do is we're going to lock, or like basically subset the data such that the data and the type 1 equals the Pokemon type. And then we'll do the same for the other one. Yep, so we'll just copy and paste this again, but we'll change it instead of special tag to speed. Okay, and next thing we have to do is we also have to, so this time instead of doing the pull patch art like we did up here, it's nice that this function has you can just add color by doing color equals color. So what this is doing is that each time we're going to be assigning it the color within our color range. And I think that's it. Oh, let's add a label too. So we're going to add each time there'll be a label, so we have a nice legend. Oop. Oops. Alrighty. What happened here? So it just did the first one, looks like. Or oh no, sorry. Let me look really quick. Interesting. What's happening here? One second, guys. Let me look at it. I'm looking at my other computer or my other monitor. Oh, let me try this. So PLT. So we're actually do this anyways, but let's just see. Okay, yeah. So apparently this doesn't work. So we'll go back to the original way that I had it. Should have just done this way. And we'll give. Oh wait, no. Sorry. Whoops. So I had it right. What I have to do is I have to, instead of doing a color, I have to do index. But this is funky. I'll change that in a second. Where is it breaking? Alright, let me just do the initial way, because I know it works. Sorry about this. And is my variable called colors or color? Yeah. Alright, let me try this now. Nope. Alright. Let me rerun this actually. Sorry guys, one second. Alright, let's just move one thing at a time, I guess. So, is it this is causing an issue? I'm guessing so. Oh, there you go. That's interesting. So, it's only showing a couple of the colors. One second, guys. So it's only showing a couple of colors. Let me add it back in. And so that's the issue. That should work. So it's not iterating through each of them. I wonder why. Because if I get rid of this, what happens? Oh well. So you can kind of see it's working. I don't know why all of them aren't showing up. Let me do p-type to make sure. Or poke type. So they're all in here. So it's only doing the first couple, which is weird. Let me do this. Let's make sure. Oh, so that's why. So why is color so short? Do I reassign color somewhere? That's the issue. Color. Yeah, so I want to reassign color somewhere. Let's see. I don't know, let's try it now. Color equals color text. There you go. Okay, so somewhere up here I must be reassigning color. Yeah, I'm not necessarily sure, but it's working now, so I'm not going to waste more time on it. But as you can see now, we have each individual type with a different color. It's a little messy, but we can kind of do some things to fix it up. So one thing we can do is we can change like the marker. So for example, if we do marker equals like O, I think this will not do anything. I think it's the same, yeah, but you can do, for example, do X's. See X's here, you can do, I think, this is one. No, maybe just one of them. No, okay, never mind. Let's go back to X's, I guess, just because it looks a little interesting. Alright, so you can kind of see here is that we have, I actually hate the X's. You can see here that we maybe have some type of thing where the lighter colors, so maybe like normal poison, those kind of things are higher, while maybe some like the grass and fire down lower. I'm not necessarily sure, and also it's pretty noisy, so there doesn't really seem any clustering of the color in the graph, so no assertions can be made about the Pokemon type in relation to speed versus special attack. Sorry about the delay there. There's something weird going on with the color variable. But yeah, this is kind of the way this is one way how you can basically like split up your data and then like plot it. Yeah, I'm gonna stop for here a minute because I know it was a little confusing. So if anyone has any questions, post them in chat. But yeah, I mean you can also do all the same stuff where you have, like you can do something like plt.xlabel, all the same stuff. Yep, there you go. And you can also increase the font size. Let's do 16. There you go. Alright, so next thing you want to do is let's say you want to do a line plot, right? So, say you have some plot, or say you want to make a line plot, right? So basically, say you're trying to do line of best fit, as we're doing here, you want to draw a line of best fit for each line plot. Yeah, and so we're going to do linear regression. So if you guys aren't familiar with that is, that basically is a line of best fit. If you are familiar, you'll be knowing what I'm talking about, but we're not going to go about this into depth what a linear regression is today. If you're interested, please come out to our machine learning workshop next week where we'll talk about linear regressions and many other machine learning algorithms. But yeah, so we're going to go ahead and do that really quick. I'm going to implement it really fast. So basically all linear regression does is that it tries to find the line of best fit through the point. So it's something similar you might have done, I don't know, back in the day, maybe in like linear, or not linear algebra, algebra 1 in like high school where you have a collection of points. For example, like, in their initial plot, the line of best fit would be something like this. So what we can do is we can do model.fit, and then we'll pass in our data, which is a data special attack dot values. And if you're interested what the dot values is, so initially this will be a data frame, and then the value just passes in just the array. We'll do the same thing, we'll pass in speed, the values, and then unfortunately it's not good enough, so what we have to do is we have to reshape it. It's basically, which don't go into too much depth about this. Basically it's a 1D, or basically it's a list and you want to change it to a 1D array, and so we'd use a reshape method. So it should work. Linear regression not defined because I have to run the cell. Yep, so your linear regression working, and then let's add our coefficients or our slope, which you can do model.coef, and then we can also, we can get intercept equals model.intercept, something like this. Yep. Then we can we'll print our let's say slope intercept. So as you can see here, we currently have like our slope and intercept, right? So if you think about it, like, y equals mx equals b, this is our m. Well, let's get this out of a vector, and then the other one is our b, so intercept, right? Yep. And we'll do this just to get it just the values and not in a what you call it, and so they're no longer in arrays, right? So yeah, so okay, so we have our slope intercept for our line of best fit. Now we can graph and see the trend on the data, right? So say we want to plot our line of best fit on this graph, right? So let's yet again, let's take the same graph, right? But we'll plot a line chart on top of it, right? So pop this down. We get our line chart again, right? But now I'll read up here. So we have our slope and intercept for line best fit. But when we talked about our line space where we get n equally spaced points between A and B, it's really useful for plotting functions. You can get a large collection of points along the x-axis, and then we can input them into our model, and it will return the y values, and they'll automatically interpolate them. So what we do is we do the same thing again. What we can do is we can do plt.plot, and this will be our line plot. We have our x and our y, which we haven't declared yet. And we'll make it the color red. And actually, I'll move this down to this plot, and then we'll declare x, right? And we'll declare our y. So our x is going to be our line space, right? So it's np.linspace between 0, and look at our max value, 200, so let's put between 200. And how many values we probably want? Let's just do maybe, I don't know, 50. And we'll do the same thing, we'll reshape it to make it a 1D array. And then what we'll do is that then we will do the intercept plus our slope times our x values, right? So this is basically create all of our y values, right? So if we run this, we'll get our x and y. If we run this, we should get our line of best fit. So you can see here is that now we kind of have like a linear regression or our line of best fit through our model, based on our model. And you can see it looks generally pretty good. There's obviously a lot of variance on either side of the line. If you were to be, asked to make this prediction, I'm guessing it'd be generally pretty low. So yeah. So this is just for overall, but say we want to do multiple lines on the same graph, right? So say, before we had just a singular one, but say we want to have a line of like a slope intercept for each type, right? And we want to plot all of them, right? So we can do the same thing again. Let me stop for a second and see if any questions. Alright, looks like we're good. So let's do the same thing again, right? So we'll do the same thing again, but we'll have to iterate. So let's do our best fit underscore data, right? Where we will store all of our slope intercepts. And basically, we're going to repeat the same process as before, but instead of it doing all the data, we're just going to basically only get certain parts. So what we'll do is say for p underscore type and pocket types, right? What we will do is we'll basically copy this process over. That's a nice thing about this. Copy this process over, but now what we'll do is that we will lock where our data type 1 equals our p type. And we'll do the same thing, just copy and paste. Copy. Oops. So this should fit the model each time. I will add a new line. So as you can see, our x and y data, x and y, where we get each time, we'll get the slope and intercept. But instead of printing it, what we're going to do is we're going to append it or add it back to our data, right? So that bestfit.data.append, and then we will add our slope intercept, right? So we'll do our slope intercept. So as you can see, we're doing the same process, but each time we're getting a new slope intercept for each Pokemon type instead. And I believe that is it. So this should get all of our Pokemon types. So if we look at best fit data, you can see, so we have our slope, best fit for, I think our first type always was what? Sorry, I'll scroll back up a little bit. Is there grass, fire, water? Okay. So this is for our grass type, our fire type. And you can see there's interesting that they have different slopes. Some are very similar. For example, these two, and they all looks like much different. Like for example, this one is negative. So let's try to plot it, right? So we'll do the same thing as before, but instead of this time we're not going to plot the data or anything. I think that's really messy. So what we'll do is we'll say is that we'll create a figure. Figure with a fixed size. Let's do 16 by 12 again. Like I said, you don't have to do size. You can do any size you want with the DPI. Let's say 60 again. And yeah, this is just something I was playing around with, and I thought this was good looking. And I'll do face color equals light. So we have a figure now, and let's put our plt.show, which is kind of just good habit to get into, so you don't have to worry about all the extra stuff. So now what we want to do is we want to basically get our x and y data, right? And then we want to plot it each time for each different color, right? So we say for I and C, where I is our index of our Pokemon and C is our color, in zip length poke underscore type, and let's say, whoops, this one would be range, and the colors we'll say in colors. Let's just do color. I'll try it again. Keep it simple. We know that works. Alright, so basically we're going to try to add a color. Basically what this color for, the C, is to change a color each time. And then the I is going to allow us to select which slope intercept we're going to do for each best fit. So if you remember, there was, this usually we do like best fit at 0, best fit at 1. This is kind of what that range length poke type. So what we'll do now is we'll do plt dots. So we have to create x and y again, which is like np dot line space between 0 to 100, say 100. Let's do reshape, make it 1, 1, y equals, so we want to do best fit data at I 0. So this will get the Pokemon type and then the intercept plus best fit data at I add 1. So this gets a slope times our x, right? And then what we'll do is we'll plot it. So we'll do plt dot plot x, y, where the color equals color, we'll say C. And let's say, let's say that the label equals poke type. Let's just say I. So this should work. Let's try it. And it doesn't. What line does it break on? Whoops, this is why I have to do color. So remember, color, this is just index. So we have to do this. Aha, okay. So as you can see, it's interesting, right? So obviously there is a big differences between the average like slope versus, here, we can add this before we start talking about it. And let's add legend. Alright, as you can see here, you can see there's some pretty significant differences in the slope. So for example, this looks like electric. This is like much different than, say, for example, like fighting or psychic. So this is like, again, as you see, there's a lot of like customization and ability within Matplotlib. You can see there's like differences in the relationship between speed and special attack depending on the type. So you want to make a question on this? It's kind of, I know it seems a little repetitive, but I just want to show everyone kind of the abilities of Matplotlib. Alright, I think, okay, so I think we have 2 more plots, so we're going to do bar plots and then subplots. So we'll do bar plots really quickly. So bar plots are really good if you want to see like the distribution of a variable, if you want to compare frequencies of attribute between categories. Bar plots are really powerful. It's probably one of the real common ones up there with scatter plots and line plots, or just plots in general. So say, so let's compare distribution of types, right? So there's all these different types. So let's see the counts of it, right? So if we do plt dot bar, where sorry, let me make sure I'm doing this right. Okay. Actually, before we even start, we can do bar. We have to basically get the count of each type, right? So we can say type counts. So basically, what we're gonna do is we're creating an empty array. Then we're gonna say for Pokemon type and poke type. Basically, then we're gonna get the count of all the number of Pokemons in that type. So we're gonna just kind of this process. So we're gonna say count equals data, where you can say dot lock data. So it's very similar to what we did for 1 equals p underscore type dot count. So this will count the number of them, and then we'll append it, right? So we'll do type count dot append count. So what this will allow us is we can kind of whoops, what's happening here? Okay, so what this is doing is asking the count of each of them. So what we'll do is we'll say we'll just get the number of names, I guess. Ah, there you go. Okay, so now we just have the number. So this is like the number, whatever the first one is, grass and so on and so forth, right? So the grass, water, fire, etc. Right? So we have our counts. So now let's actually plot it, right? So we'll do the same thing as always. Create our figure with a plt.figure so we can plot on it and not worry about overlapping. Because if you don't, you worry about something I think it's kind of lighting and not really working. And let's do the DPI, let's say 60, and then say, I don't know, do we care? No, let's not change the face color this time. So what we do is we can say a plt.bar, where our X is our labels, right? So this would be, for example, like grass fire, poke type, and then our Y would be our counts, right? So we can do type counts. So if you see, we can kind of see our types, and there you go, right? So let's do our plt.show again. Ta-da! So okay. So what we can also do is that this is even nicer, is that instead of us doing the whole looping thing with the color, we can simply just do color equals colors. Whoop, color. Aha, so this is even better, right? So instead of having to do the whole thing where you loop through each color and assign individually and plot on the same figure multiple times, we can all do it in one foul swoop. So as you can see here, water type is the highest, flying type is the lowest, and yeah, you can kind of see the trend. So as you can probably guess, wow, that's interesting actually. So the three star types of grass, fire, and water are even, like, for example, fire is pretty low and like bug and normal are much higher. So it's pretty interesting, even something like psychic. So you can kind of see interesting distributions. You can also do this within variables to say you're doing something like, I don't know, height, right? You want to plot the heights of it, you could do this as well. And yeah, that's kind of it. Another thing you can do is you can compare the frequency of a specific type based on if it was primary or secondary, meaning that, like, alright, so this is only the primary type, or like the type 1. How many of it is type 2? So basically you have two bar charts for each type next to each other. So let's go ahead and do that, and this will be kind of our last chart. So again, we basically want to copy and paste this over again, and actually we'll rename this to be 1, which specifies the type 1. And then we'll copy and paste this down here, but replace this with 2, specify the second type. As you can see here, this is the second type frequency. Obviously, it looks like a lot lower besides flying. There's a lot of flying types, secondary. So yet again, we can kind of do the same thing. It's actually a really similar process. The only difference is, oops. So if we do this, well, so here, I'll show you what happens. So if we do this again, right, and you copy this twice over, you'll notice what happens is that a lot of times only the second one shows because they're on top of each other, right? So what you have to do is you have to kind of offset one plot from each other. And yeah, so the way you do that is you basically say, sorry. Okay, one other thing we have to do here, oops, actually let's just delete this just for, so we talked about how these colors are overlapping, And the first thing we have to do is we have to basically create like an offset variable that basically tells the thing how each plot to offset each other, right? So if you know, if this one's supposed to be here, we want this one to be over a little bit and this one to be down. So we create an offset variable. So the way we do that is we create this variable that's called index, or np.range, or mostly the length of the poke type. So this basically tells us like indexes, and then we create another one called like a bar width, bar, let's go width, and let's just create it. I'm gonna do 0.35 because I know that looks good. Obviously, when doing this in real time, you have to probably do it. Test and check. So what you do here is you do one with the index, whoops, and this will offset the bars. And then what we'll also do, well, let's do this really quick. Whoa, 1 second. That's not what I meant. Oh, sorry. So if I think the example wants a horizontal plot, which we do with bar h instead of not h bar. Interesting. 1 sec. Let me look. Okay, so instead of doing type counts or poke type, you do. Sorry, I'm getting a little confused. You do index type counts bar width, and then you do the same thing again, but you do. Okay, yeah. So this is how you do it. So you do index plus bar width type counts, and then you do bar width. Bar width is not defined. I disagree. Oh, it is. Wait, don't misspell it. Okay, here you go. So we can actually probably change this to be just a normal bar graph. Let's see. There you go. Okay, so one thing that happens here, sorry, I'm getting a little frazzled. One thing that happens is that, we see this is probably for primary and secondary, but we lose our labels. So when we do that is we can do plt.yticks, and all we do is we say, we can our poke type. Okay, so one thing we have to do actually is we have to add where to put it. So we do index plus bar, so with, basically we're going to do divided by 2, so it's just in the center. It should work. X ticks, not Y ticks. And there you go. Alright, so sorry about that confusion, but basically what we do is that we have our index, so it says at 0, right? And this will plot our first one. So we index, for example, this is 0 right here, and it gives a certain bar width. Then what we do is we add another one, index plus a bar width, so you go over a little bit, and then you plot the same thing, but for the second one. For the Y ticks, what we do is that we basically say, okay, we want to go over, start at 1, and then add half it to be in the center of the 2, and then we add our types. That's basically it. So that's kind of a way to create like a staggered or like multiple bar charts within one that kind of makes sense. So yep, that's kind of, yep. So we can see Pokemon type 1 and Pokemon type 2. So really interesting is like the flying type. Not many things are like a primary flying, but a lot of things are secondary. I don't think there's any other examples of that. Maybe poison. There's a lot of secondary poisons. I don't know, fairy, but not that's the standard. Anyways, so you can probably make some assumptions, right? That like, for example, flying, poison, ground, fairy, for example, are like mainly secondary, right? Something along those lines. I'm not sure. That's basically bar plots in a nutshell, and you can make them horizontal as well. So you don't like it, whatever. and you can make this y ticks. Whoops, regardless. And you can see the same thing, right? So that's kind of it for bar plots. Any questions? I'll stop for a second. Alright, and now we're going to finish a subplot. So as you probably noticed, we've only ever done one plot at a time. And that's kind of simple, right? So most time you'll want to maybe compare multiple plots at the same time. So you can kind of mix and match different plots. So say one plot you want like a bar plot and then a scatter plot and so on and so forth. So the way you do that is I will quickly show you. I know it's going kind of long. Is you instead of doing a plt data figure, you do plt.subplot. So x equals plt.subplots where you say and columns, let's just say is 2, and rows, let's say e is equal to 2. Then you can do the same thing for like, fig size equals, let's just say 10 by 10, or let's do 16 by 12. That's kind of, alright, let's do 10 by 10. So why not? And yeah, so we can do multiple plots. The way you do that is you say, x, which basically is like lets you individual. It's basically can be an array of your different places where you can plot. So you figure it's like the entire thing, right? And your x is going to be what you put inside of each place. And so since you're having a 2 by 2, it's going to be two-dimensional. So you do x at 0, 0 will give you the top left one. X at 0, 1 will give you the top right one. So on and so forth. Let's put some stuff in here just to show. Okay. So for example, let's say we in the top left put a scatter plot. plt.scatter where we have data, and let's do maybe our special tag for speed again. Tag versus data. Okay, that'll be our whatever our speed. Let's do our box plots maybe. So let's do plt.boxplot, and let's say a box data. I think we saw that variable. Box plot. I think box data. Let's see. And then this other one. Let's do a bar chart. So plt.bar. With our polka type, and then our what's the name of our bar data column? Type counts 1, for example. Let's do the last one, for example. Let's do a I don't know, a line chart, right, or a line plot. So let's do plt.plot x and y. Whoops, and what happened here? Okay, this is why. So you don't do plt equals, you just do this, plt dot. Let's do plt.show. And as you can, okay, so this looks obviously a little crowded, and you could do the same kind of optimizations as you did earlier, but instead of doing your plt dot whatever, you do your x. So for example, if you wanted to do here, x 0, 0, and instead there's some little difference in syntax, so you set x label, and let's just say equal to what is it? Special attack. Is this x or? Let's just call it yeah, I think special attack. Yep, so you can do the same kind of stuff, but this is basically just to show that you can do multiple plots. This is probably one of the most useful parts of Matplotlib besides the individual plots itself, is that you can have kind of a collection here showing multiple different things. You can then, something like you can save this figure. For example, if you do like a fig dot save fig, for example, and you can for example, say it, example. .png. You get this example, and then you can take this, put this in a PowerPoint, do whatever you want with it, right? So it's very powerful. Also, you can just literally screen snippet or screenshot and then take the parts you want. But yeah, so this is really useful if you're working at any job with data analysis. You have to, at some point or another, you're gonna have to create a visualization to show what you did and kind of what results you're having. And analysis is really helpful in exploratory data analysis when you're trying to figure out kind of what the data represents and that kind of stuff. So this is the end of it. This is a very high level overview of what you can do in Matplotlib. Like I stated earlier, if you have any questions, feel free to ask in chat, but also Google it if you're trying to do something very specific. Sometimes the syntax is pretty messy or specific. As you saw the entire time, I was kind of looking over at my second monitor just to kind of see what it is, because it's easy to forget. But yeah, and I also included links for each of them about their documentation. And yeah, that's kind of it. So concluding remarks, which I'll kind of restate here. Today I showed you some of the basic features and plots of Matplotlib. Matplotlib is an extensive library with lots of functionality, lots of types of documentation. If you want to try to plot something in a specific way, then you can Google it and probably find a solution online. The official Matplotlib website is at the link provided. And that's basically it. So I hope everyone enjoyed the DSI workshop today. I really appreciate everyone coming out and learning more. If you're viewing this at a later date, feel free to like and subscribe. We'll be having more workshops coming up. I believe next 2 weeks are going to be our machine learning, which I think are some of our more fun workshops where we kind of talk about, and the first week we talk about at a high level what some of the machine learning algorithms are, kind of dichotomy of it, and explain at a high level and kind of talk about them. And the second week we do a lot of implementation. So we're going to give a data set, and we're going to then kind of show you what these are, how to implement them, how they perform, that kind of stuff. So definitely keep a lookout on that. Please go to our Facebook to keep informed. It's probably the best way to do it. And yeah, I appreciate everyone coming out and listening. And yeah, see you guys. I'll stick around for a couple minutes to answer any questions if there's anyone remaining. Yeah, that's basically it. Have a good night, guys. All right, that's it. Oh, yep, you're welcome, WordWrap. If you have any more questions, feel free to, um, you can message me now. You can, yeah, you can also look online too. So really appreciate everyone coming out. This is the end of the stream for tonight. Like I said, upcoming workshops I'm really excited for. And if you want us to cover a specific topic that we maybe you don't think we're doing best of, feel free to email us or add it in the sign-in sheet. Really appreciate it. That's it from me. Talk to you guys next.